Hello. In this video, we're going to look at solving inequalities. Now, you can solve inequalities by using a graph or factoring, but you can also solve them using sign diagrams. Now, let's do a bit of a recall. Let's say you had x squared and you wanted to find when that was greater than or equal to 1. So one thing you could do is use a graph. That would be a good method because you take x squared, which is just your simple parabola, and then you take the line y equals to 1, and you see where's the graph above that line. Well, of course, it's going to be in this section and this section. It would be important to find the points of intersection between the two, and we know that for the parabola it goes over 1 and up 1. So this is going to be over at 1 and then over at 1. So we could have our solution, therefore, negative infinity to negative 1 union 1 to infinity. Now, another way to solve this would be with some factoring. We could move the negative 1 to the other side, and then we could factor it down as x minus 1, x plus 1 is greater than or equal to 0. But from here it's a little tricky because we have to figure out, well, how do we get a positive number out of this? You could do some testing, and of course you'll get equal to 0 when x is equal to 1 or x is equal to negative 1. And I guess you'll get positive if they're both positive or both negative, and you could do a little bit of logic back and forth, but a sign diagram really simplifies this type of reasoning. Because if we're looking for where this is greater than or equal to 0, we're really saying where is this quantity positive? And then of course where is exactly 0? So if we treat this like a sign diagram, we have a point here at 1 where it's 0 and a point at negative 1. If we pick a number bigger than 1 to test, maybe we test 10, you get positive and positive. As you cross the 1, it becomes negative, and then as you cross the other one, it becomes positive. So here we can see very clearly that the solution is happening here and here. Of course, we include the negative 1 and the 1 because that's where it's equal to 0. And so this gives us the same solution we would have right here, negative infinity to negative 1, that would be this portion of the number line, and then 1 to infinity, that would be this portion of the number line. And so the sign diagram is a very useful tool. Now the method is as follows. Step 1 is you want to move everything to one side of the inequality. You don't want to do anything where you have other stuff on both sides or you cross multiply, and the reason why, just if you're wondering, is because if you think about it, you can't know for sure if x is positive or negative. And so any type of multiplying or cross multiplying will be very dangerous. If we look down here, you might say, oh, I'm going to cross multiply this. I don't want to do step 1, I want to cross multiply. But when you multiply an inequality, if x is negative, it reverses the inequality. And so because you can't know for sure if x is positive or negative, you can't cross multiply. That's not a valid technique here. So what you have to do is move everything to one side like we did initially. Step 2 then is we create a sign diagram using our sign diagram method, and then step 3 is we determine the interval. So let's try this example here. Step 1, like I said, is a little bit annoying because you want to cross multiply. It's been what you've been trained to do in math, but unfortunately you have to move it to the other side, and you have to get a 0 on that right-hand side. Now we have to combine all this to draw a sign diagram, which means we need to make common denominator. So over here, this one looks like it's going to be missing an x plus 1. So we'll multiply by x plus 1. And this one over here is missing an x minus 1. So multiply by x minus 1. So that's going to give us, well, 2x plus 1 times x plus 1 minus x minus 1 over x minus 1, x plus 1. Now it's important as we're doing math that we realize when we want to expand and when we don't. In this case, the bottom is already factored for us, so we don't want to expand there because we're going to have to factor it back down to draw our sign diagram. It's a waste of our time to expand this only to factor it later. But in the numerator, we have to expand this because we have to find a way to simplify this term and eventually factor it. The numerator is not factored because it's not all multiplication. Notice the key difference. In the bottom, it's one term times another term. But in the top, we've got the subtraction. So unfortunately, we have to do some multiplication up here. So that's going to give us, with FOIL, 2x squared plus 2x plus x plus 1 minus x, and then that negative is going to distribute to give us a plus 1 over x minus 1, x plus 1. So we keep going over here and get 2x squared plus 2x plus an x minus an x is a 2x. And then 1 plus 1 will be 2. Over x minus 1, x plus 1, less than or equal to 0. Now you can check, using the discriminant, that this numerator will not factor, unfortunately. This is as far as it goes. So this is fully factored. It's just one term up there. Let's go ahead and draw our sign diagram down here. We know that when x is equal to 1, it's undefined. So we get a hole there and a hole at minus 1. Neither one of them are even, so we're good to go. Let's pick a number bigger than 1, maybe say 10. It's going to be positive, positive, positive. So we get positive here, negative here, positive here. Which means we need to answer this question. Where is this less than or equal to 0? Well, it's less than 0, it's negative in this portion here. And it's never actually equal to 0 because on these points here, we have the expression being undefined. So it's not actually equal to 0 there because they're open circles. So our final answer then would be this interval here. So we therefore negative 1 to 1. That would be our interval where the inequality is true. Now for homework, you can try the Inequalities worksheet 1 to 16. And just as a heads up, on question number 4, you might see this weird symbol. It looks like a circle with a slash through it. It's called the empty set, and what it means is simply nothing. It's the way of drawing an interval with, well, no points in it, right? It's as if you had an interval that looked like that, or really an interval that looked like that. There's nothing in here. But these look silly because you haven't put any numbers. And even this, if you're thinking about this as set brackets, it just looks a little bit silly. So mathematicians invented a special symbol called the empty set. It's not 0 because if the value where the inequality was true was 0, that would be a point. It means that there's literally nothing. There's no point where the inequality is true. So you could say never. Never would be another option. But in mathematics, another symbol for never, or for having no place where the inequality is true, means you could write a 0 with a slash through it, which is the empty set. So go ahead and give those questions a try on the Inequalities worksheet. And as always, thanks for watching.